Welcome to Master Mathematics in Minutes. Today's topic is about the addition and subtraction of algebraic fractions. And we'll cover a couple examples on how to add and subtract fractions. And we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, how do we add and subtract algebraic fractions? We can add and subtract fractions with a common denominator. So with p over a plus q over a, because these two share the same common denominator, we can add the numerator. And that becomes p plus q on the numerator over a, which is the denominator. Similarly, with p over a minus q over a. And because they share the same denominator, we can subtract the numerator. And that becomes p minus q over a. So, now we have p over a plus q over b. We have a case where the denominator is different across these two fractions. So the way we can sum these fractions is to restate these two fractions using the same common denominator. So starting with the first fraction, with p over a, which is that p over a, we'll multiply the numerator and denominator by b. And that leaves the value as unchanged, but we have the terms b multiplied on both the numerator and denominator. And similarly, for the second fraction, which is q over b, with q over b, and this time we'll multiply the numerator and denominator by a. So both q multiplied by a over b multiplied by a. And we now have these two fractions stated with a common denominator, which is a multiplied by b. And because of that, we're able to sum the numerator, and that becomes pb plus qa. Similarly, to subtract these two fractions, p over a minus q over b, we'll need to state these two fractions so that they have the same common denominator. So p over a is that p over a, and once again we'll multiply the numerator and denominator by b. We'll copy the minus sign, copy the q over b, and multiply the second fraction by a. And now we have the two fractions with the same common denominator, which is ab. And we can proceed to subtract the numerator, which is pb minus qa. Let's take a look at a couple examples now. In the first example, we're asked to simplify the fractions a over 5 plus 2a over 5. Now, because these two fractions share the same common denominator, we're able to sum the numerator. So that becomes a plus 2a over 5. And simplifying that further, that becomes 3a over 5. In the second example, we're asked to simplify the fractions 29x over 52 minus 4x over 52. And once again, these two fractions share the same common denominator. And because of that, we're able to subtract the numerator. So we'll state the common denominator as 52, and the numerator then becomes 29x minus 4x. And simplifying that further, we have 25x over 52. In the third example, we're asked to simplify the fractions 5 over 16p plus 7 over 8p. Now these two fractions do not have the same common denominator, and so we'll need to restate the second fraction so that it matches the denominator of the first fraction. So we'll copy 5 over 16p across, copy the plus sign across, and we'll multiply the numerator and denominator of the second fraction by 2. And it becomes 7 multiplied by 2 over 8p multiplied by 2. So 8p multiplied by 2 is actually 16p. So it matches the denominator of the first fraction. And because of that, we're able to sum the numerator. And so that becomes 5 plus 7 multiplied by 2 over 16p. and simplifying that further with 19 over 16p. In the fourth example, we're asked to simplify the fractions s over 5 minus 2s over 25. Now, these two fractions do not have the same common denominator, so we'll need to restate the first fraction. So we'll multiply the numerator and denominator by 5, and that becomes s multiplied by 5 over 5 multiplied by 5. So 5 multiplied by 5 is actually 25, so it matches the denominator of the second fraction. So we'll copy the minus across, and we'll copy the second fraction across, which is 2s over 25. Now, because these two share the same common denominator, we're able to subtract the numerator, and that becomes s multiplied by 5 minus 2s over 25. And that becomes 3s over 25. In the fifth example, we're asked to simplify the fractions 5g over 7 plus 3g over 10. So these two fractions do not have the same common denominator, and so we'll need to restate both fractions so that they have the same common denominator. Starting with the first one, we have 5g over 7. We'll multiply both the numerator and denominator by 10, and that becomes 5g multiplied by 10 over 7 multiplied by 10. We'll carry the plus sign across, and for the second fraction, we have 3g over 10, and we'll multiply both the numerator and denominator by 7, and that becomes 3g multiplied by 7 over 10 multiplied by 7. We now have these two fractions stated with the same common denominator, which is 7 multiplied by 10, and we can carry that across. And because of that, we're able to sum the numerator, and that becomes 5g multiplied by 10 plus 3g multiplied by 7. So that simplifies to 71g over 70. In the final example, we're asked to simplify the fractions 19y over 20 minus y over 3. And once again, these two fractions do not share the same common denominator, and so we'll need to restate both so that they have the same common denominator. Starting with the first one, we have 19y over 20, and we'll multiply both the numerator and denominator by 3. And that becomes 19y multiplied by 3 over 20 multiplied by 3. We'll copy the minus sign across, and for the second fraction, which is y over 3, we'll multiply both the numerator and denominator by 20. And so that becomes y multiplied by 20 over 3 multiplied by 20. So we now have these two fractions stated on the same common denominator, which is 20 multiplied by 3, and we can carry that across. And because of that, we're able to subtract the numerator, and that becomes 19y multiplied by 3 minus y multiplied by 20. And that simplifies to 37y over 60. To summarize, we can add and subtract fractions with a common denominator. So p over a plus q over a becomes p plus q over a. And p over a minus q over a, that becomes p minus q over a. And in a case where the two fractions do not share the same common denominator, we'll need to rebase both fractions. So p over a becomes p multiplied by b over a multiplied by b. We'll carry the plus sign across, and q over b becomes q multiplied by a over b multiplied by a. So we have the same common denominator as ab. So we can sum the numerator, and that becomes pb plus qa. And similarly, for p over a minus q over b, that simplifies to pb minus qa over ab, after rebasing these two fractions with the same common denominator. Thank you very much for watching. This is Master Mathematics in Minutes.